Alright folks, it's Mass Action Back in Action here. In this video, we're going to go through some examples using law of sines. Even if you haven't watched a video that goes through the proof of law of sines, you can still apply it because the formula is pretty simple. So up here at the top of the page, you can see that I have this formula, okay? I've got these three ratios, three fractions set equal to each other, and I've got a triangle drawn over here. So what law of sines tells us is that within a given triangle, so my triangle here is ECB, okay? Within a given triangle, the ratio of any side measure divided by the sine of the angle across from it will remain consistent throughout the triangle. So E divided by the sine of E is equal to side B divided by the sine of angle B and side C divided by the angle C. That ratio will remain consistent throughout the triangle. Now, in a later video, we'll talk about some special cases, but in general, this is just pretty easy to plug in. When you set up the three ratios, you'll typically be able to find two of them where you'll know three of the four parts of the two ratios for the proportion. So let's jump into a word problem, because it's always good to practice a word problem. So in this word problem, it says that we have a pilot that's flying an airplane on a bearing of north 90 degree east. So what that means is that our pilot here is actually just traveling due east, okay? So we have some place, let's say right here, this is his path of travel heading due east, and then there's some destination over here that he wants to get to. Now, what he notices is that there's a thunderstorm between him and his final destination, so he's going to change course and he's going to turn the plane 25 degrees north. So as he turns his plane 25 degrees north, we're going to put our 25 degrees there. It says that he's going to travel on that path now for 92 miles. Eventually, he's going to make a turn, and he's going to go turn through an angle of 105 degrees back towards his original destination. So he's going to eventually head back towards this original destination. But this through an angle is really significant. And what we need to imagine here is that his path of travel is extended, and the through an angle is how much the nose of his plane has turned through this angle right here. So this is the angle that's 105 degrees. And then we're going to go ahead and fill in that supplement of 75 degrees. Once we have these two angles in our triangle, we can of course fill in the third angle in the triangle over here of 80 degrees because we know they all add to 180. Now what I can do is I can go ahead and put some variables on the two sides of the triangle that I don't know. I'm going to call them A and B. And using my law of sines, I can set up my three ratios. So I can identify the fact that 92 over the sine of 80 will be equal to my side A over the sine of 25 degrees, which will be equal to side B over the sine of 75 degrees. Now, if a law of sines is going to apply, one of these ratios is going to have two parts, and we can see it's right here. I call that, when we look in the picture, I call that a link, okay? If you have a side and the angle across from it, that's a link. That's your sign that you're going to be able to use law of sines. Now, what we can do is we can pick any two of these ratios and set them together and solve for our missing parts. Now, let's take a look at our first question and decide what we want to find first. So our first question says is how far will he fly after making the second turn? That means we want to find A. Now, sometimes I'll just actually do my work from the three ratios right there, but especially as we're learning, it doesn't necessarily hurt to go ahead and rewrite the two ratios that we want to use to help you see how this algebra is going to work. So we're going to have our 92 over our sine 80, and that's going to equal our side A, because that's what we want, over the sine of 25. When I cross multiply that, I end up with my A times my sine of 80 is equal to my 92 times my sine 25. Remember, it's always easier when you write these if you have some type of a integer or a variable to put that on the front end. It's going to make it easier for our calculator work. Since we're solving for A, we're going to divide both sides by sine 80. Remember, that's just a number in our calculator. These will cancel, and then we'll be able to just type this in our calculator and get our value for our side A. And you can type that in your calculator just as you see. Make sure that your calculator is in degree mode. It's a really easy thing to accidentally get flipped to radians, and then none of your answers will make sense. I tend to make that mistake. So if we type this in, we should be able to get 39.5 miles is how far he went after that second turn. Now the next question that we want to answer is how far off course did the storm cause him to travel? That means that we want to compare how far did he actually go, this 92 plus this side A, compared to what he would have done if he hadn't had to turn. So what we're doing mathematically here is we're looking at what did he actually travel. Actually, we'll keep messing that up whenever I write that. Okay, we've got our actual travel minus his planned travel. His actual is going to be the 92 plus that 39.5 that we just found, but then we need to subtract off what he had originally planned to do. So we need to calculate that. So if I want to do that, I'm going to do it in my extra space up here. I've got my 92 over my sine 80 and my b over my sine 75. And when you get comfortable with this, it's pretty easy to visualize the algebra, the cross multiplying that we did on that part A, and you should be able to get that your side B is 90.2. So that was all he wanted to travel, so we can substitute that in now down here. If we go ahead and finish off that arithmetic, we get that he went 41.3 miles out of the way. And that, of course, is going to be important for him as he's calculating his fuel and how much he has left and knowing how far he can still go. All right, let's look at one more example here at the bottom that's pretty basic. You'll notice I already drew a triangle for this one, so you might need to pause and redraw that triangle. I wanted to go through this one just again to help you remember that when we look at this problem, first of all, we have two angles already. We know all the angles in our triangle should add to 180, so we can automatically fill in that third angle of 45 degrees. Once we fill that in, we can look at our triangle, look to see if there's somewhere in the triangle where we know the measure of a side and the angle across. That's going to be our link, so sure enough, we know that we'll be able to use our law of sines. So when we go to set this up, you'll notice that I gave you this improper or this mixed number. We want to convert this to an improper number. We don't want to convert it straight to a decimal in case that decimal is not a terminating decimal. So we're going to go ahead and convert this to our improper fraction. We're going to write it as a 29 over 8. And then we can go ahead and set up our law of sines. So now we'll say 29 over 8 over the sine of 45, that's the angle across. I'm going to go ahead and put some sides now on these, on the sides of my triangle. So put a little b for the side across from B. I'll put a c across for the side across from side C, or angle C. And then I can say b over the sine of 25 is going to equal c over the sine of 110. And just like before, if we go ahead and we do our cross multiplication and we can solve these, we can find our missing parts. Remember, if you want to solve for b, you can either rewrite it or just focus on these two ratios to create your proportion, and you should be able to get that side b is approximately 2.2. The rounding instructions on the worksheet will be pretty particular, but in general, I take side measures to tenths and angles to the whole number. When we want to solve for c, we don't really want to use that b again, so we're going to go back to this nice original ratio that has both parts, and then we'll use our last one. Again, you can either rewrite it or just work from that set of three ratios, but you should get your side c is approximately 4.8, and of course we already found angle A was 45 degrees. Okay, so when we're in class, we will go through some more examples, and we're also going to look at how to find area of a triangle.